Okay, so here is a second solution to this problem. In my other video, I show the White Rose Math suggested solution. What I've done in this solution is to try and use less math knowledge, if that makes sense. What I'm trying to do is to use the bar model more, use it to show me what I would need to do. So, how someone with less knowledge might go about doing it. So, someone who'd been playing around with bar models, or at least that's my intention. So, a car factory makes different colored cars. 40% of the cars it makes are black, 60% of the remaining cars, and that's important, are silver. The rest of the cars are white. There are 5,628 more black cars than silver cars. We're then told that some black cars are sold, and the black cars now make up 10% of the total cars. And we're asked how many black cars were sold. So this really is quite a complicated question. Lots of different things going on. You're going to have to be careful of which amount something is a percentage of, because things are taken out of the problem, as it were. But let's give it a go. As I said, this is a different approach to a very different approach to White Rose Maths approach. But the idea is that I'm trying to approach it from the point of view of someone who knows less, basically. Right, so where are we starting? I'm going to start here where it says 40% of the cars that it makes are black. So I'm going to draw a bar, and because it's percentages, I'm going to draw a bar to represent the total amount. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, as usual, badly drawn, but hey ho, that's pen and paper for you. Right, so 40% of the cars it makes are black. One, two, three, four. I obviously split this into 10 equal parts. So, and I'm going to label it. So that's the black cars. And then it says 60% of the remaining cars are silver. Okay, so it's not Um, so this is 60% obviously of the total. And in the White Rose math solution, what they do is then calculate 60% of 60. But I'm not sure that I want to do it in a way that someone who didn't realize or doesn't know how to do that could approach this. So 60% of the remaining cars are silver. How many parts have I got left? One, two, three, four, five, six. I've got six parts, and I want to split that into 60%. So really what I would it would have been much better had there been 10 parts, wouldn't there? Or five parts or something like that. So what I might think is I'm dealing in tenths, and I'm also dealing in sixths here. So what I might think is that I would like to have the least common multiple of 6 and 10. That would make it easy to split things up. And that would be 30. So I want to split this into 30 parts, this whole bit into 30 parts, which means splitting each of these into fifths, into five parts. Okay. So that's what I'm going to do. Obviously, it'll take me a little while, but not too long. It's not a difficult thing to do. And it doesn't have to be perfect. It just has to be good enough for me, the one that's using the model, to know what I'm doing. And again, this is why I don't use the computerized apps, because I want to be able to replicate what it would be like if you were using pen and paper. Otherwise, because you obviously can't use a computer in your test or something. And actually, if I'm going to split these up, I'm going to split these up because I want to keep the parts equal. Okay, so this, I'm just going to mark that. So the black, this is 5, 10, 15, 20. Black now, that's 20 parts. Okay, and then here I've got 30 parts in total. So what would 60% of 30 parts? Well, there's 50 parts in this whole thing, but I want to have 60% of this 30, so 6/10 of the 30. And so you might think this, I want 6/10, and I've got, what would that be in 30ths? Well, and that gives me 18. So I think that some of my younger mathematicians might be able to figure that out. So 5, 10, 15, 16, 17, 18. So that's where I'm going to draw my line. So this is the silver cars, and I'm going to, it's going to help me, I think, if I just make a note that that's 30 parts, and the remaining cars are white. So here we go, and that must be 12. Okay, 12 parts white. Okay, so I think I've got all my information there. So that's that done, that done, that done. Now we're told that there are 5,628 more black cars than silver cars. So the black cars, I've got 20 parts. The silver cars, I have 18 parts. Now, I could redraw this to have, well, actually, just, we I don't need to, but let's say, so let's say, and I'm not going to do all the subdivisions. I'm just going to say I know that that's 20 parts, and we're going to have, this is the silver, that's 18 parts. The difference between them is obviously 2 parts. So this 2 parts has a value of 5,628. And I'm going to use a different color. There we go, 5,628. So we now know that every 2 parts is 5,628. Well, let's find out what one part is, what the value of one part is. So that's 5,628 divided by 2, and we get 2,814. So in this model, one part, I don't know what, okay, is 2,814. Okay, so each of these, I now have a value attributed to each of those. What else do I need to work out then? Okay, so it says some black cars are sold, so some of these are going are disappearing, and the black cars now make up 10% of the total cars. So in the new value, in the new total, black cars, the new value of black cars is going to make up 10% of the total. Now, what you also need to realize is that it says black cars are sold, but no silver or white cars are sold. So in the new value, in the new total, the silver and white cars are going to make up the 90%. All right. And so we need to find out how many cars are represented here. So what have we got? We've got 18 plus 12. Okay. That's our 30 parts. All right. So 30 parts is 90% of new total. Okay. And so we want 2,814. 2,814 multiplied by 30. And that is going to give us 84,420. Okay, so 84,420. Now, again, it depends on the level of maths of the person drawing this. They now know that this is 90%. You could, of course, draw another bar, and you could think, okay, now I've got my new total, all right, and okay, and then this is going to be the black cars at 10%, and this is the silver and white, the 90%, and I now have a value for that. Okay, so 84,420. So how do I work this out? Well, if we divide, we could divide it by 90 and then multiply by 10 to get here, but actually we're just going to divide by 9. So 84,420, we need to divide that by 9 to give us 9,380, and that's giving us 10%. So that is the value here. All right, so 9,380. What is that? Well, that's how many black cars were left. Let's go back and look at what questions were asked. What the question that were asked how many black cars were sold. Okay, so we need to know how many cars we had in the first place. Now, in the first place, there were 20 parts of black, and one part being 2,814. So what's that? Let's do that up here. 2,814 times 20, and we get 56,280. So that's how many black cars we had in the first place. This is how many black cars we have now. So to get our final answer, it's going to be 56,280 minus 9,380, which gives us 46,900, which is our final answer. So 46,900. Okay, so do look at the other video if you want to see how White Rose Maths solved this. They just assumed I think, high level ability. I was just trying to think that if you were really doing it in a bar model way and you couldn't figure out what you needed to do, this is how you could use a bar model to tell you what calculations to do. Anyway, I hope that helps.